This is a problem from your lab assignments, section 3.9. It says here that the length of a rectangle is increasing at a rate of 5 centimeters per second, and its width is increasing at 4 centimeters per second. When the length is 14 centimeters and the width is 12, how fast is the area of the rectangle increasing? So it looks like we're going to want to use the area formula. Area is equal to length times width. And so we're going to take the derivative of this, and the derivative of the area is going to be a product, because L is going to be a function of time. It's increasing with respect to time, and W, the width, is also a function of time. So it looks like we have the first times the derivative of the second. So that's dW dt plus W times the derivative of the first. So it's second times the derivative of the first. So product rule allows us to find our derivative. And now it says here we must evaluate dA dt. The values of L and W are given in the original problem, so we have a few numbers here to deal with. This is increasing at a rate of 5 centimeters, so this is going to be some sort of derivative, and so is this 4 centimeters per second. So you can see the units also will help in determining what those numbers are. Here we have the length is 14 centimeters and the width is 12, so it looks like the length is going to be 14 and then the width is going to be 12. So we're going to get to put that in for L and W, and then now we know that the derivatives also are rates, so centimeters per second. This is the width, and so the rectangle, the length is increasing at 5 centimeters, and then the width is increasing at 4 centimeters per second. So the width is 4 centimeters per second and the length is increasing at 5 centimeters per second. So now that we have these actual numerical values, we're just going to put them into the formula. And so we have L times dW dt. So L is equal to 14 times dW dt, which is 4. So 4 times 14, I think I'm going to need a calculator for this. 4 times 14, I probably didn't need a calculator. That's 56. And then we're going to add W times dL dt. So W was 12, dL dt was 5, so that's 60. So add 60 to this, and we get 116. So that should be our answer. And the units also would match 116 square centimeters per second. So it's the area that's changing. So we want to make sure that the units match. Okay, I hope that helps.